Okay, hello YouTube and everyone. Today I'm gonna learn about hypothesis testing. Yeah, it's an interesting topic, let's say. And let's get going. First, we're gonna thank our sponsor for helping us making this video today. And what is hypothesis testing? So it's a statistical method we use to make decisions about a population using sample data. And why we use it is because data is arrived by chance, so we need a formal rule to decide if an observed effect is real or random. It's like water boil at 100 degrees, either it's real or it's random. So we have to do that. And this is the hypothesis testing framework. It starts from step 1 to step 6, from making state hypothesis to finally decide to make decisions. And in our first step, we have defined x0, which have no effect, relationship is null, and h1 have effect and relationship is an alternative. And I mean, if we put it into a person, so x0 is a kind of cautious guy, kind of conservative, always assuming that nothing new is happened and it won't change their mind unless you show them strong evidence. While H1 is curious and kind of energetic. The guys always believe something is happening and there's an effect or relationship. So the guy always step in when evidence is strong enough to reject H0. So I think H0 is kind of hate this guy. And his role in like kind of person who always think that there's always something wrong. But yeah, that always something wrong. I don't know what it always look like, but yeah. Next one is significant level alpha, is the threshold for risk and error. We usually set it at 0.05, and it's the rule for how much evidence it needs to reject H0. I mean, basically, if we set it 0.05, we are saying that we accept that our result would have 5% error max, and if it surpass 5%, we reject H0. Next is test statistic and p-value. So the test statistic is a number that measures how far our data is wrong, what the null hypothesis H0 predicts, and depending on the test, it could be t, z, x squared, or f value. It's pretty simple. And if you make an example, like imagine you are testing whether people can really taste like the difference between Coke and Pepsi in a blind taste test. So H0 is people guess randomly, like no real difference. While H1 is like, yeah, people can actually tell the difference. I don't know who can do that, but let's just say that they can actually tell the difference. And if 80 out of 100% pick correctly, the test statistic measure how unusual that is, like under random guessing, like how unusual that is, and that's a test statistic. Next, we're gonna talk about our p-value. So from the test statistic, we calculate our p-value, and the p-value answer if H0 or 2, how surprising would my result be? A small p-value means that the data would be very surprising in the H0, which give it evidence against it. That's why when a p-value is smaller than 5%, we usually reject it. I will reject it actually. And we have an example. So suppose a candy company say that they back 50% red candy. H0 say that the bag has 50% candy, like the red candy, like the company say, and you open a bag of 20 candy and you find 18 red one. The p-value answer to the question is that if the bag actually have 50% red candy, what the actual chance that I would randomly get 18 or more reds out of 20? And basically p-value answer the question that how surprising the data would be if H0 were 2, and in this case, I don't think this would 2, as well you open 20 and find 18. That's really high. Yeah. So it's make the p-value very small. So mean result is too unlikely and H0, and we doubt that the company actually saying the right thing. Final is when we decide to make decision, when we have p-value and we have the evidence decided. So if p-value is smaller than alpha or significant level, the evidence is strong enough, so we reject H0 and spot H1. If p-value is stronger or larger or equal to alpha significant level, we fail to reject H0, meaning that the evidence is not strong enough to move away from the default assumptions. And sometimes we make decisions with error. And that's why we have two type errors and power, which I'm going to talk later. So type 1 of error is false positive, rejecting a true H0, while type 2 error is a false negative, failing to reject a false H0. So if H0 were 2 and we reject H0, it's type 1 error. If H0 was false, we fail to reject it, it's type 2 error. And power is the opposite of type 2. We basically say that if our tests are good enough, then there shouldn't be any error in the first place. And we shouldn't fail to reject our H0 because it's already detected and already reject H0 if it's false. Here is our example. So type 1 error is a COVID test, say that you don't have virus when you actually don't. Type 2 is that you are fine, but when you actually have COVID, the test say you are fine. Power is a good test that should correctly detect the virus when it's really there. And yeah, that is all the framework of hypothesis testing. Next, we're gonna have some case studies.
The next day.
Okay, so in here I have the database of the Central Park squirrel in 2018 from New York, and already download the file, so we can look at what our squirrel fan are doing. So we have date, we have shift AM PM, we have age, we have primary fur color, highlight fur color, combination of that both color, and all the activities that the squirrel are doing, like eating upside down a tree, really good ones, wrestling with mother, and someone else like mornings, tail flagging, running from humans, and I guess what I'll do is choose some easy topic to talk about. H. Let's do is juvenile squirrel run from humans more than adult squirrel run from humans? Yeah, this I do that type of testing. Okay. First, we have to upload it to our collab. Google Collab. I'm gonna do it on Google Collab. To upload it, and we have to clean it too. So do it. Okay. We have to import pandas and also import the file from our computer. It's an Excel file. Okay. This one. Okay. And from this, well, that first, we have to clean it, right?
5 minutes later.
And yeah, yeah. Spotify. Okay. Start up sweet time. Scroll. Check. Again. Okay, we have the file. And next one, do we, well, do hypothesis testing? Load the file first. Okay, load the file. We also have to make a table to do this testing. I think I just gotta make a table so it look better. Cross tab and diff. Okay. Runs from. Let's see, it just runs from, right? Yep. Okay. Let's just try to print the content. Print the table. Check it. Okay. If we have that 1000 well 1997 out of squirrel don't run from human. Why 571 run from humans? We have 81s 09 squirrel run from human. Why 249 doesn't run from human? Okay, I'm gonna do some categorical, and it's only 2 subjects, so I think I'm gonna do G-square test. And I think to do G-square test we have to import it. Forgot to import it. Got something okay. Let's actually write. Can't. We'll have to choose a file again. Shit. Okay. Oh my god, I make the same mistake twice. Damn it. Okay. Start good. I'm gonna do G-square test. Okay, do some p-value and okay. Here we have a tree square, we have p-value, VOFs. Okay, and a p-value is 0.3a, which means it's bigger, much bigger than 0.05. So out. Yep. So our H1 is not really right. So 09s or idle scroll, no one is run from human more than the other. So yeah, they both run from human in the same value, same index. Okay. Yeah, I think that's all to look at. Thank you for watching.